In this paper, we present Popup Light Field, an interactive system for image-based modeling and rendering. Our system takes a sparse light field as input and renders smoothly without aliasing. The basic idea of the Popup light field is to use layers. When the light field is sparse, it cannot be rendered without aliasing using conventional light field rendering. If we put the focal plane on the front object, a double image occurs in the background. By moving the focal plane back and forth, we can focus on different parts of the scene, but a single focal plane is not sufficient to render the whole scene without aliasing. In our system, the user pops up layers one by one. Each pop-up layer represents part of the light field that can be rendered without aliasing using a single plane. By adding enough layers, the whole scene can be rendered. This example shows that 4 layers, including the background layer, are enough to render this 2 by 5 by 5 light field. If we downsample the light field to 3 by 3, we can still achieve the same rendering quality by increasing the number of layers to 7. A pop-up light field is represented by a set of coherent layers. Each coherent layer has simple planar geometry, but requires accurate layer boundaries. To construct coherent layers, we propose coherence matting to accurately estimate the alpha values on layer boundaries. This zoomed-up view shows the boundaries are correctly segmented and matted using coherent matting. This is the comparison between video matting and coherent matting. Coherence matting maintains better temporal coherence of the alpha channel across frames. This is another example of coherence matting, and its comparison to video matting. Again, coherent matting has more consistent alpha estimation across the sequence. This alpha coherence is very important for anti-aliased rendering. A coherent layer can be represented using either globally defined geometry or view-dependent geometry. This sequence is composed of 42 images taken with unstructured camera motion. Images are very sparse, with a wide range of viewpoints. Therefore, a single global plane for all the views leads to rendering artifacts, but better rendering can be obtained by changing the plane orientation in different views. To model the pop-up light field, we have designed a user interface to construct coherent layers. We now demonstrate how to pop up a layer in the light field with our user interface. A new layer is created by the user. By using the polygon lasso tool, the user can cut out a layer in a keyframe. Then the user selects another keyframe to find the corresponding segmentation. The user can refine some points if necessary. The system propagates the segmentation to all the other frames. The user can then refine more points if necessary. Finally, we get a popped-up layer that can be used by coherent matting. We now show some rendering results of popped-up light fields. This scene is composed of 9 by 9 images taken at a regular grid, captured using a computer-controlled table. The scene is modeled using 4 coherent layers. This furry toy is captured by moving a digital camera along a line. The scene is rendered using 5 coherent layers. This plaza data is taken by time-frozen cameras. From 16 frames of the original sequence, we render the scene smoothly by constructing 16 coherent layers. In conclusion, when the input light field is sparse, a pop-up light field can still achieve anti-aliased rendering by constructing coherent layers. The key is not to construct accurate depth for each pixel, but rather to accurately segment layers using coherent matting.